The last problem, what you said, what will be the input and output?
Okay, so the input are integers in a sequence, right? So 1, 2, 3, 4, 5, 6, 7, 8, any sequence. Let's say from 0 to 8 for now. Okay? So what you're doing is you're missing one digit, 8.
Okay.
And in one pass you're figuring out which integer you're missing. If you had millions of numbers and you don't want to use, so here's the thing, right? This integer is either present or it's not present.
Okay.
Right? You don't have to worry about duplicates, you don't have to worry about this not being within this particular range, whatever it is. You can have n number of digits that are absent, and then in just one pass you can figure out what digits are absent. Right?
But it will take too much space, correct?
No?
Millions
Of
making it
bits,
one.
right? So what is millions of bits? 8 bit is 1 byte. So 32 bits is like one integer. Correct?
But,
We'll see how-
your example, you still showed it as a lookup, right?
Yes, I still showed it up as a lookup so that you understand.
Okay.
You are doing that at the bit level, not at the byte level.
So one more thing. So
Yes.
let's suppose there are two of the bits that are not set.
Yes.
So the missing number would be like combination of these. Right?
No.
No, two numbers are missing, two separate numbers are missing.
So two separate numbers are missing, right?
I think it's more than two because what if like I think if I understood correctly, you are actually setting the bits from starting from 0 all the way till,
Yes.
and every bit represents every
One
single
integer.
number.
Yes.
Right. It's still like a lookup.
So even, okay, if you are thinking that I am setting 4 as 1, sorry, let's say I'm setting 5 as 1, 0, 1, 1, then no.
No, it's not like that.
It's
I am
not-
setting 5 as 1, 2, 3, 4 and 5. So I'm setting this bit. This number is actually 2 to the power 5,
Okay.
right? Okay. So let's do simple addition. I know everybody knows this. We are going through this because we will need this in masks when we create masks. 1 plus 0 is 1. 1 plus 1 is 1, 0. This is 1. If you want to do it as this, it is going to be 2, 4, 6, 8. So 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Correct? Is 0, sorry, 1, 2, 4 and 8. So now this number is 3 and this number is 10. So the total should be 13. This is 13. Correct? And 1 is the only one that gives you a 1, otherwise everything else returns a 0. XOR. What will we get for this?
0 triple 1.
0, 1, 1, 0.
XOR, when you XOR anything by itself, it's a 0. When you XOR only with its negation, you get a 1. So XOR with anything by itself is going to be 0. Let's start coding. The first problem is get bit. Boolean get bit integer I integer position. The question is, let's say I give you an integer big.
Yeah.
question is, let's say you have an integer I. Integer is 32 bit. I am going to write only 4 bits. This is again an example. 1001. Now, if I were to ask you that find the value at position 3, how will you do that? Is it set or is it not set? So it's a boolean. If it is set, then you return a 1. If it's not set, you return a 0.
Multiply it by 1, shift, and if you take 0, then 0.
Okay. So what you do is you take a mask. Oh, I actually forgot to explain this. Before we get into this, one is a left shift, one is a right shift. So let's say you have one left shift 3 times. What will the value be? So right now this value actually is indicated like this. It shifts 3 times. So this is 1, this is 2, this is 3. Correct? Similarly, right shift, the value will actually shift to the right. Left shift and right shift are good when you are multiplying or dividing by 2, because it is very easy to shift the bytes to the left by 1, whereas it is difficult to, it is time consuming to actually multiply that value by 2, because at the end it has to get translated as left shift by 2 and then it gets translated, and instead you are doing the manual labor yourself. So one easy trick is to left shift by 1 when you are dividing, when you are multiplying by 2, when you are dividing by 2, you right shift by 1. So here you say return mask and position not equal to 0. Mask and mask and integer not equal to 0. So what's this going to do is, this is going to left shift 1 by the number of times where we want to find the bit set or not, and then you are ANDing it with mask. So everything else at this point in time in mask is 0 other than the 1 for which we want. Everything else is going to be 0. Now if the value is 0, it means the value at that position was 0. Correct? So if it becomes equal to 0, when it becomes not equal to 0, so when this is 0, you will return false. If it is not 0, then you return true. Make sense? Integer set bit integer I, integer position. What you are saying is, I give you an integer irrespective of what is present in the position location, set it to 1. Set that bit to 1. Again. Int mask equal to 1 left shifted position times
Or in place of that.
in place of AND, yes, you will do an OR. So I OR mask. Question?
No.
Done? Now we'll say clear bit. So int clear bit int I int position. Irrespective of what the bit is at position in the integer I, make it 0. Make it 0. So we'll start off the same way. Int mask is equal to 1 left position left shift position times downward.
XOR.
Okay, so let's say you had this value and I ask you to reset this, and if you XOR with this, it becomes 0. But what if it was 0?
Okay.
It will become 1.
Yeah. Right shift it with position plus 1
Okay,
and then AND it with position plus 1.
so I am right shifting what? The number or the mask?
The mask
Okay, so instead of 1,
position,
you
you will make it position plus 1.
okay, 1 right shift
No,
position,
no, left shift only. Sorry.
left shift only, okay,
Position plus 1.
position plus 1,
Okay, now the position will have, position plus 1 will have 1 and after that it will be a 0.
Just negate the
Negate and
mask.
AND.
so mask
So can't
left
take
shift,
this one as 0.
what's that?
Just take mask as 0.
No, so the value is always 0, right? All zeros.
So if we take mask as 0 and we do XOR or OR.
If you do mask as 0 and XOR, so XOR will not work as
Sorry, if
you
we
said
take
it.
AND. If we
AND.
take mask as 0 and do AND.
And okay, so the way what you are trying to do is that will work, but it will not work in this case. What you are trying to do is int mask equal to negation of 0.
Yeah, just
This is
0.
all ones.
So I'm just taking 0, all 0.
Okay, so you are taking all zeros,
Yeah,
and then
and then
this is your value, like say 1010. I want to clear this bit.
oh, then I will do also the clear. Yeah,
Close the window.
yeah, I got it.
So now, when you do this, you have inverted the only one that you wanted to reverse has become 0, everything else is 1. So you will say return mask and I. Now, if I want to clear all the bits from I to the most significant bit, so I'll say from this bit to this bit, turn everything to 0. So it should be something like this. So this is your I, this is your MSB, this is your position, and this is your integer.
Create a mask of all zeros
Mm-hmm.
and 1 1
All zeros,
and 1 1.
meaning.
Up to the position.
Up to the
0.
position 4 0 and 1.
So you want a mask till this ones and this
Yeah.
zeros?
Yeah.
How? It's always a matter of getting the right mask and then doing the right operation. How you get the mask is a trick. How will you get this mask? Yes, you're right. If we get this and if we AND, so our trick is to get the mask as MSB to position we want 0, from position plus 1 to LSB we want 1s. Correct? So how will we do it?
Left shift and OR with one.
Okay, so you left shift, let's say you left shift 3 times, so you have 1, you left shift 1 time, you 2 time, 3 time. Okay, now you OR it with 1.
Everything is for loop, so still not formulated.
Okay.
So
Sure, take your time. The trick is you want all zeros and all ones. These are zeros, these are ones. How did you get it?
give me the 2's complement of
I'll show you one simple math and then you'll get the trick. What will this give you?
0,
This is 1 0. This becomes 1 or 1 0. Similarly, it will keep going till the time you get this 0, this 1. Is it in the same format that you want it? So what you're doing is, this is easy, left shift till the time you reach the position.
So mask minus
Exactly. So you left shift till the position, subtract 1 from it, and you get it. Clear MSB to position given integer I and integer position in mask equal to 1 left shifted position times mask 1 is equal to 1, or let's keep it simple. Correct? Then at this point in time you will just return mask and
check. When you will shift, it will be 1 0. So we are moving,
till the time I reach the position.
we are making all 1 and 0, right?
Yes.
When you're moving, and then we are shifting, and you're doing.
So let's say if I wanted to do 3 shifts, correct?
So
My position will go to the third one.
yeah. So third will be 1 and other 2 will be 0.
Other 2 will be 0.
And
I am going MSB 2 position included. If you want to exclude the position, you will have to do position plus 1. Making sense?
so can we run an example?
Sure.
Let's say.
So let's say, take this example, right? What is the position? 0, 1, 2,
Yeah.
right? So you shifted 1 time, 2 times,
So it's 1. Yeah.
correct? Now you subtract it from 1,
So 0 1 1.
0, 1, 1. This is again, this is in, so if you were to look at it, 0, 1, 1. I'll put zeros here. If you want position excluded, then you will shift one more time. You can still get it.
But here's the thing,
Yeah.
when you are saying it's a 8-bit integer, right?
Yes.
So
No,
you're-
it's 4-byte integer.
4-byte integer, but any number you're representing it will be, so 1 0 0 is represented with 0 0 0 0 0 1 0 0, right?
Lost you.
Um, so this will be represented this way, right?
Yes, it will have
So
all
when
zeros.
you do this,
Yep.
it will be
No,
No,
no, it will end at 1.
no,
we don't have any.
all of these will be zeros.
You are borrowing from that 1.
You are borrowing from this one, so this one becomes 0.
That becomes 0 and it ends there.
And then we don't have any.
There is no more borrowing.
Okay, yeah.
Clear? Now we are doing clear LSB to this position. So I want to convert this integer to 0 0 0 1 0. This should be the answer. Let's keep it as answer.
So,
Okay.
101, right?
1 0 1 0 0.
Sorry. Sorry, you're right.
1 0 1.
101 and then 000. The third position onwards.
Same mark, just negative. And then
Okay. You sure? Same mask?
negate it.
So mask position will be 1 minus, I guess.
Okay. So let's say you have int same mask will look something like 1 left shifted position times and then minus 1, correct?
Then negate it.
Okay. So mask, negation of mask. So your position is 0 1 2. So you have 1 0 0. You make it 0 1 1. Now you are negating it. So all ones.
So we need to make it position plus
Position
1.
plus 1. please.
Okay. Is there anything else you can think of? It will work. Position plus 1 will work. This is just the basics. I want to show you another trick. Think. So your this mask at this point in time and your negation of mask looks like this. Correct? Will it work if I subtract this from all ones? Right?
So take the negation,
Negation of 0.
and then subtract.
So write it big.
Okay. Let's combine the previous this problem.
Given solved in the career cup book. I don't know, manipulate bits or replace bits. Okay. Replace bits. The problem is you are given one integer m. Integer n. In this particular integer, from position I to position j, you have to replace everything that is in int m. We are not, it's very clearly said that you don't have to worry about the border conditions. So whatever it is, it's always going to be a golden scenario. How will we do this? So let's say you are given 1 0 1 0 1 1 0 0 1. This is your I, this is your j, and for this you have to, this is your n, you have to put m here. So let's say you have, so now your value will look something like, this is the same, and this middle part changes to 0 1 0 1. Two problems together. MSB to position you are maintaining, position to LSB you are maintaining, rest you are replacing. One hint, don't try to solve it together. Part 1, part 2, part 3.
So we create first mask and
We'll take the left mask,
we'll
we'll take a right mask,
and
and
negative.
then you'll clear it out,
Yeah.
and then you will left shift M and add it with whatever you have, or it with whatever you have. Correct? Make sense? So I create a left mask, negation of 0, minus 1, left shifted j times minus 1.
Just a question, Jay. Is there a possibility like M has more number of digits than
Yes, there is a possibility. That's why I very clearly said
boundary condition?
that no boundary
So
conditions.
we are assuming that the length of
Yes, M is exactly between is exactly what I and j gives you,
Okay.
the difference of I and j.
So in that case, we probably don't need the J. We just start with the I and then we keep going until the M.
This is the problem in career talk. That's why I did not argue with you. her method, it took me like half an hour to understand the problem.
Okay.
That's why I was that.
I didn't get more bits. Both are
So, what if M was, make sense? Right now we are assuming that M is exactly gonna fit here. What if it was not going to fit here? That becomes a boundary condition.
okay.
Am I making sense? No?
Yeah, I thought the problem was okay. So
Yes, no boundary conditions.
not boundary conditions. I thought the problem was basically take the bits I to j from M and replace them
No,
I to j.
take the bits in I to j, within the I to j from n, remove them
Okay.
and put these over here.
Okay.
So your right will look something like 1 minus 1 left shift I times 1 is 1. Now this is the tricky part, left or right, because you want both the masks to remain intact. Here you are clearing the values in between. What will we do here? You cleared the values. So this now looks like this.
So M shifted by I.
M should shifted. How much? You should write. This is your value.
Oh, actually.
Comes here 1, 2, 3. That's it. Yes. Should I write here? Okay. Now a trick question for you. What does this mean? And what does it tell you about n? When it's satisfied? It's fun. Yes. It's power of 2.
That's the most common question asked. I think first question asked
Yep.
in bit.
Anybody wanna figure out why?
And operation between
A value and
All
some
ones
two
and
ways to
no.
zero to ways to-
One and MSB.
using this, how can you find the number of bits set in an integer?
You keep doing that operation till you remember number of times you do that operation. So we are counting the bits.
Yes, set. Bits
Set
set.
bits. Yeah. So when it becomes 0,
Mhm.
then number of times you go through the operation is 0.
Stop.
So,
Just drag big and so that
we say like
just drag big so that you can see. Okay.
so while I'll put some condition over here,
Okay.
and then we say we have some counter,
Mm-hmm.
and then we say I and I minus 1 equals to 0. Actually, that becomes a condition. Return your count.
Walk through an example.
So let's have 3,
Mm-hmm.
which is 0.
Let's say you have 5.
Let's say we have 5. So now we have 5.
One more.
This is
Yes. Okay.
this
You have
is
5.
This is 5.
It's
right?
fine. Yeah.
And now you do that 5 minus 5, that operation with 4.
Mm-hmm.
4 is
100.
and then it becomes
100.
yeah, sorry, 100. And when you do the AND operation, it becomes 100, and the count becomes
Hang on. So it becomes 100. Is it equal to 0?
no.
So then we just go in.
No, just count.
Yeah, yeah. So yeah,
Okay. Now try for 4.
yeah, and then we
No, now try for 4. Look at 5.
okay.
Yeah.
So with the 4, we do with the 3, 0,
Mhm.
0.
Will you go in?
But why would it come the second time?
Yeah,
Okay.
so let's actually put the 2 by every side.
Okay.
Put the condition
Then
over here, right? You put this condition over here.
okay. Are you sure that's the condition that we should loop on? Let's say you have 3 ones. Will it work?
We have
3 ones.
yeah,
Okay. See?
like this.
Okay. So you will go in, first time you will go inside no matter what, and you'll increment the count. So count is becoming 1, and then your 111 will become 110. At that time it will break out of the loop.
And I think that is
So here's the thing, every time you do and the value is diminishing, the value is reducing.
right.
So by the time it's going to become 0, so you can just say while I and
Yeah, yes.
While I is greater than 0 and
While
is equal
I-
to n minus 1.
I and equal to I minus 1
We have to assign that value back to the I so that it keeps on reducing.
Yeah. Family trick.
communication doesn't
So just return, if you just get I, return hello. Yes. It's getting stuffy, right? Yeah, no, this guy told me like he wants to do this, so that's why I put the camera and did this thing. I don't know if it helps. Hopefully it helps. Yeah, so that's why like the light is coming. That's why I was making up and down. Now I can't see this. Okay. Okay. I'll write on the reference. Oh, okay. I'll I'll adjust it so that you can also see. I do it. Okay. Let's say you are given a value, an integer. Now you have to swap the odd and the even bits with each other. So it will be 0, 1, actually, I can't write this. 0, you are swapping these, swapping these, swapping these, and swapping these. It looks something like this. Correct? How will you do this? Try to break the problem down. Don't do it in one step. Okay. All odd values are now becoming even values. Okay. All the values at the odd position are now going at the even position. And everything at the even position is going to the odd position.
You need two marks.
Okay.
1 0 1 0 1 0 and 0 1 0 1 0 1.
Okay.
You get two numbers and kind of you shift and do
Or
or.
so you wanna first have an odd mask and even mask. Correct?
Yeah.
So your odd mask will look something like this. Your even mask will look something like this. If you look at this value, this is 5, this is 10. Or in hexadecimal it is 8. Now when you OR it with this, over here you will only have odd digits. If you left shift by 1, they will become all even digits. When you OR it with this and right shift by 1, your even will become odd. Then you OR it. Swap, odd, even, this, integer I. This one is your even, so you are right shifting by 1, or one line of code, but 8. It's just it's 8 bytes. Ah, 32 bits, right?
Okay. But like rest of the things will be
So
zero.
it's 4 bits, right? 1010.
Yeah.
4 is a 32 bits.
So each A represents 10.
Yes, so
Okay.
1010. This is an integer, it's 4 bytes. Over here I have used a shorter example.
Okay.
That's all. This is a palindrome. How do you find if the given integer is a palindrome at the bits level?
Can you do it with the, you can't do it with the string level, right? And the array index.
You can, if you can access the values. So you have to figure out this value should be matched with this, right?
Yeah.
Can you figure that one out on the fly?
With the method we wrote earlier, I get
Get bits and
Okay, so you can keep pushing in the stack, and
and then when you match it, you pop it. And if it doesn't match, you delete it.
okay. Right.
The right solution. Okay.
Think from bits perspective, bits level, shifting, and, or.
if we do XOR,
Mm-hmm. XOR of
XOR of half of that number, I mean, the same number.
what is half?
uh,
Okay, what is a palindrome?
Palindrome.
Reverse and the same string.
So if I were to bring this one here, 1, 1, 0, 0, 1, 0, 1, 0,
Shift
0,
into the
1, 1.
One.
If I XOR it, what will be the answer?
0.
So if the value and its reverse are XORed and you get a 0, then it's a palindrome. Otherwise it's not. Question is, how will you reverse? Remember, when you're trying to reverse, there are trailing zeros that need to show up there. So if you are thinking that when I found the last one and I pushed the one there, you're done, you're not. You have to still have to add these zeros at the end. This is just an example. one bad thing about the get count of number of ones is we actually ignored the number of zeros between two ones. Because when you add it with 1 minus of this will go away. In the next iteration, this will go away. You can't really say how many zeros were there between those two ones. Okay. At every point in time, we are going to look only at the last value, right? And that is the value that you care. That is the value that you have to start left shifting. So, how will you do that?
Okay,
So let's say your number is num and your answer is ANS.
take the
So your yes.
number, you
Mhm.
always add it with 1.
Okay. So
You
your
get the bit,
number you add it with 1.
1. You get the bit, and you
Uh-huh.
shift that bit by the length.
So here you got the bit. You don't care what that bit is.
Yeah.
Correct? Right? You found the last bit.
Okay, you kind of
You put it at the end.
got it.
You left shift by 1. Correct? And then what?
You go all the way till
How?
number n and n minus 1.
N and n minus 1. Are you sure? That's what I said. If you have 1 0 0 1, the first iteration it will become 1 0 0.